Hello students of class 9, welcome to my next online class. So today I am not conducting the interactive classes. I have chosen this YouTube video to teach you. So this is the continuation video of the same chapter, that is spherical mirror. So in my last class, in my interactive classes also, we have discussed what are the different types of spherical mirror, that is convex mirror and concave mirror. So convex mirrors are those mirrors in which the reflecting surface is outside the hollow sphere, that means reflecting surface is outside. Okay, so this mirror is called convex and this mirror is called concave, right? So concave mirrors are those mirrors where reflecting surface is inside the hollow sphere. So you see the silver coating is inside the hollow sphere is for convex and silver coating is outside for the concave mirror. Okay, so these are the two types of mirror. Now convex mirror is also called as diverging mirror and concave mirror is also called as converging mirror. Okay, so what concave is called converging and why convex is called diverging, this one we will see now. So concave mirror is called here the converging mirror because whenever rays of light parallel to the principal axis falls on this mirror, after reflection they pass through a fixed point, that is F, that is from principal focus. So all the lights are seems to pass through a fixed point, that is called here F, right? So therefore this is called converging mirror. So concave mirror is called here converging mirror. Now whereas convex mirror is called here as diverging mirror because whenever rays of light are falling on the outer reflecting surface of this hollow sphere, that is for in convex mirror, the rays appear to diverge from a fixed point, that is F. So here the rays, as rays are diverging from a fixed point, it is called diverging mirror, and as the rays are converging at a fixed point, so it is called here converging mirror, right? So this is the simple things. So you need to write and you need to draw the diagram if it is asked why convex is called diverging and why concave is called converging, right? So this was all there. Now in my last class also I have explained the different terms related to the convex and concave. Like the geometric center of mirror is called pole. The center of the sphere of which mirror is a part is called center of curvature. The imaginary line joining the pole and the center of curvature is called principal axis, and principal focus is a point on the principal axis where all the light meet after reflection from the spherical mirror. So we have learned last class center of curvature, pole, principal focus, also focal length, that is the distance between focus and pole is called focal length, right? So these terms are very important and you need to memorize these terms nicely, right? So let's see now what is the relation between R and F. So R stands for here radius of curvature. So radius of curvature means the distance from C to P, from center of curvature to the pole is called the radius of curvature. This distance is called here R, right? So this R, what is the relation between R and small f? So you see whenever the light is falling here parallel to the principal axis, it will pass through focus, and if any light is passing to center of curvature, then it will act as a normal, right? Here the angle of incidence equals to angle of reflection. So Cp, that means this distance from C to P equals to Cf plus Fp. We can write this one Cp equals to Cf plus Fp. What is Fp here? Focal length. That means from F to P is your focal length. Similarly from C to F, this is also focal length. Okay, same focal length here we get. So F plus F in place of Cf F and in place of Fp F. So F plus F is 2F. That means F equals to R by 2. So this is the relation between focal length and radius of curvature. If I say the radius of curvature of the mirror is 15 centimeter, then what will be its focal length? That means 15 divided by 2, that is 7.5. Or if it is 20 centimeter, then it will be 10 centimeter. Radius of curvature, if it is 20, then focal length will be 10. That means half. Half of radius of curvature is focal length, right? So these are the important terms. Now we will see what are the rules of drawing the images of a convex mirror. What are the rules? Now there are 4 rules are there. Like for example, if first rule is saying that if we have a concave mirror, and this is the principal axis, right? This is the pole and this is the center of curvature. Whenever any light will pass parallel to the principal axis, it will pass through focus. So this is rule number 1. So rules of drawing images. Rules of drawing images of concave mirror. Okay, rules of drawing images analysis of concave mirror. So first rule is saying that whenever a ray of light is passing or traveling parallel to the principal axis, after reflection it will pass through focus. Rule number 1. Rule number 2 is saying that if this is the concave mirror again, if any ray of light is passing through focus, that means it will pass parallel to the principal axis. This is rule number 2. That means this is the converse of this. If any light is passing parallel, it will pass through focus. If any light is passing through focus, it will pass parallel to the principal axis, right? Rule number 3 is saying that in a concave mirror, if any light is passing through center of curvature, if a ray of light is passing through center of curvature, after reflection it will come back in the same path. Okay, so this is rule number 3. Rule number 4 is saying that a concave mirror, principal axis, and whenever a ray of light is falling on the pole, then it will reflect back in the same medium, such that angle of incidence equals to angle of reflection, and principal axis acts as a normal. Okay, so this is the principal axis which will be acting as a normal. Okay, so these are the 4 rules of drawing images of the concave mirror. So convex mirror, so maximum questions you will practice for the concave mirror. So convex mirror also you will practice, but most preference you will be giving for concave, these 4 rules. So similar 4 rules we have for convex also, but you practice maximum for concave, right? So when you will see in a book, you will find that for the convex, you see whenever ray of light is parallel, it is moving away, that means it is diverging, but rays are meeting at focus. So from here also it is clear that if a ray of light is parallel to principal axis, it will pass through focus, right? Similarly, if an ray of light is passing through center of curvature, so it is falling outside, it is reflecting from outside, but if you produce here, it seems that it is coming from center of curvature. So whenever a light passes through center of curvature, it passes the same path, that means it travels the same path here. So rule number 1, rule number 2, rule number 3 is if any ray of light is passing through focus, so it will pass parallel to the principal axis, right? Next law is saying that if any ray of light is falling on the pole, it will travel in the same medium such that an angle of incidence equals to angle of reflection. So these are the 4 rules which we have, which will be practicing for convex, and these are the 4 rules which we will be practicing for concave mirror. So location of images, we have will be finding for this by using these rays, the rules which we have learnt now. By these rules we will be finding the location of images found by the object. First one is that when object is at infinity, so light travels on the concave mirror, and after reflection they try to form the image at focus. So when the object is at infinity, the image is found at focus. This is rule number or the diagram number 1. Next, when the object is beyond the center of curvature, so when the object is beyond the center of curvature, you see one from the tip of this object, one line will go parallel and it will pass through focus, and second line it will pass through center of curvature. You see these 2 lines, that means the line which is passing through focus and the line which is passing through center of curvature, they intersect at a fixed point, that is A dash and B dash. So A dash and B dash are the images, right? So what is the nature of the image? Image is formed between F and C, between focus and center of curvature, and it is real and inverted and dynamiced, right? Similarly, when an object is placed at center of curvature, the image is also formed at center of curvature, that means same size of that object. So first line will go parallel to principal axis, it will pass through focus. Now if it passes through focus, it will pass parallel to principal axis. So like these 2 images will intersect, and the image and the object will occur at the same place, right? So this was the nature, enlarged and magnified, real and inverted, and beyond the center of curvature. So where the object is being placed, same here, image is being placed here. So for object placed at center of curvature, image is also placed at center of curvature. It is of same size and inverted in nature. So next you will see when an object is placed between center of curvature and F. Between focus and center of curvature, when an object is placed, it will pass parallel to the principal axis and pass through the focus, and light passing through center of curvature will pass the same path. So image is formed beyond the center of curvature, right? and the nature of the image, size of the image is enlarged and magnified, real and inverted. And what is the position of the image? Beyond the center of curvature. So last we will find that when a ray of light, when an object is placed at focus. So in the first diagram we have seen when light is coming from infinity, image is formed at focus. Now it's the converse path. When an object is placed at focus, image will be formed at infinity. Okay, so each and every diagram you might have noticed that one ray always it is passing through focus and one ray it is passing through center of curvature. So what will be its nature? The image is formed at, if an object is placed at focus, image at infinity, real inverted and highly magnified. Okay, and this is the diagram which will get virtual image. So till now all other 5 diagrams will get all the real image, because image and object are in the same direction, same side, but here image is formed in the backward of the mirror, so it will give an enlarged image. Okay, virtual image here. So these diagrams you need to practice, and you have to make the table in your exercise book. If you remember, we have made in the class 8 also. So like this table you will make and add one more column where you will draw the diagrams, small diagrams, right? And sign convention and this one will go in the next online class. Okay, so till then only this much. So practice these questions or practice these diagrams in your exercise book. See you soon.